This meeting is being recorded. This meeting is being recorded.
Right. Welcome this afternoon to the CAWASA Wednesday webinars. We're happy to have all of you here with us. If it's Wednesday, it's CAWASA Wednesday webinar. And today we're going to have our presenters from CLEARFLOW. We do not have Hank with us just yet, owing to some technical difficulties. And I must make mention of our sponsor, that is Operators Without Borders, and Valerie Jenkinson is with us this afternoon. And she has been very helpful in finding us some of our presenters. So thank you, Valerie, and welcome back with us. And we want to wish you a very good year. And to all of you who are joining us for the first time this year, again, it's not too late to wish you a happy new year. I know the folk at Wasco going through some challenges now trying to get water to people in the north of the island. So we know we will not have many of them this afternoon, but this afternoon we're going to have Hank will be represented by his partner here, who I will yield the floor to and who will introduce himself since I didn't get his bio. So please proceed.
Sure. Hello, everyone, and thanks for this opportunity to talk today. I'm Jerry Hanna. I'm the owner and founder of ClearFlow Group, dating back to 2005 when we started the company up. I've invented the gel flocculant formulations that we have been using for almost the last 20 years, as well as much of the equipment. So I'm the crazy science guy they lock up in the basement with a mad hairdo, I guess, and do all that crazy stuff and bring it out to the world here. So we've been very fortunate in working with the mining and municipal and wastewater processes. We're in 7 countries now, and I spend much of my time now focusing on just the science, but also working out of along with the University of Alberta, where our home office is. Working with students and helping to develop students in the next generation of water and wastewater treatment people, and scientists. We have an office in Phoenix, Arizona, which I'm down in Phoenix right now. Unfortunately, I'm not at our office. I'm going for surgery tomorrow morning, first thing. So I've taken the day off to be at home and just do this last presentation before I go into the anesthetics, I guess you could say, or I might be under them now. I don't know. I'll have to check. Anyways, moving forward, Hank put this presentation together. He was at a couple of big conferences lately. So there's a couple of slides about me here. We'll quickly go through that. You don't need that. We've won numerous awards for environmental safety, environmental conservationism, and engineering and design. So I've been doing this now in the mining sector specifically for about 20 years. I've been in the water industry since 1978 in one form or another, working for major corporations or just for myself the last 25 years. So it's a little information there. I'm going to go through a little bit of an overview of what ClearFlow or who ClearFlow is. Our ASRT, which is Accelerated Sediment Reduction Technology, and then how we look to restore, preserve, and repurpose water. Also have some information that we'll talk about a little bit on stormwater and stormwater applications, specific to TSS reductions and phosphorus reduction, things that are becoming quite evident in today's applications that are causing damage to the environment, especially on the phosphorus side and algal blooms and things like that through cyanic bacteria, etc. A little bit of an overview about ClearFlow. As I say, we've treated over almost 8 billion liters of water in the last 20 years, and we continue to advance that number dramatically every year as we progress. So it's kind of a large number. As I said, we're in 7 countries. We've got various distributors in each country right now. In Canada, we have Mabrex, Paradox, and a couple other smaller ones. Those are the two larger ones in Quebec and across Canada. We're United Kingdom and Europe. We have Frog Environmental. South America, we have Alpha Water and DeFiltro. Australia, we've just aligned with Eris out of Brisbane, and they handle water treatment and wastewater treatment all over Australia. And we've got CAWASA Group in Saudi Arabia, and we're just, as of last week, signed on a new distributor for North America that's in a mining specific field called Megadrain. And we are now also looking at aligning with a group out of Indonesia and another group that we're looking out of Chile. So it seems to be water is a big worldwide concern, and we're very proud to be part of it. Who are we? Well, we're a team of professional engineers, chemists, water experts dedicated to environmental sustainability. We used to say everything is environmentally friendly. I don't know if that's always a good term, but we like to say that we're adding quality to water for the environment and repurposing it. Environmental friendly is such a widely used word, and in some cases it gets hidden by its own meaning. So, we really looked at repurposing, making it safe for aquatic organisms and also, mammals, humans, etc. So that's really where we try to stick. We're a manufacturer. We manufacture our own products and formulations and distribute them, as I said, worldwide. Also, innovative processes that optimize the use with the gel flocculant that we've invented as a medium for getting it into other applications, either in line or in situ. So water, as I said, restoration, preservation, repurposing is what we do. And really, restoration of industrial and stormwater back to its naturally clean state, preservation of watersheds and surrounding aquatic habitats and environments, and repurposing of industrial and stormwater and wastewater to minimize impact on natural bodies of water. When we designed this, when I started this technology, what I did not go after was the standard process of flocculation coagulation. What I looked at was a combination of flocculation, coagulation, thickening, dispersants, looked at all various types, right down to the simplicity of starch and how that has worked over hundreds of years and things like that. Really looked into various processes and chemistries to see how I could combine them to come out with the most optimum application. So what I looked at wasn't the water itself. Water to us is a byproduct. What I looked at was particles. And I said, look, if I have a particle, what's the particle density? What's the specific gravity? What's the charge of the particles? How does it adsorb or absorb materials? And by doing that, it changed the whole engineering process involved in water treatment. And what I also looked at was, to me, the number one factor involved in water treatment was not the chemistry you're using or trying to get the water to a point. What I looked at was time. If I can reduce time and accelerate the process, can I reduce footprint? Can I reduce energy usage and greenhouse gas emissions, et cetera, et cetera? So what's its carbon footprint? What's its time footprint? And what's its physical footprint? So that's really what I looked at. And by doing the application of just releasing enough to cause the particle to do what I want it to do was way different than just dosing up the water so much that there's potential for overdosing, impact on the environment, and creating a deleterious waste stream. So basically, that's the process that I used in it. So to us, particles are the critical mass. And whether that be a metal-based particle, organic-based particle, or inorganic of any type, we look at that. So we do ask for samples. Flocculation, of course, we all have pretty common thing is flocculation, and it's a process where chemical flocculant, coagulant added to water facilitates bonding between particles and creating larger aggregates that are easier to separate. Our goal initially wasn't to cause the separation, but to cause the particle large enough to capture. The beauty of it was we did it so well, we were able to really, really clean the water down at the quantum level. So we're below 1 micron in particle sizes that we're dealing with. We're down in many cases, we're down to dissolved particle size, dissolved colloidal particles, etc. So we're now getting into some very unique strata in water treatment. Very simple picture here from left to right, of course, the dirty water, then partially flocculated water, and then of course the deposition, allowing you for a clean water. Jar test demo. I'm not going to do that here today. I don't have the stuff. That was what Hank was going to do as part of this. But basically, it's a very simple process, 10 to 45 seconds. You mix it around and the deposition starts virtually immediately. And we're looking at a ratio that we can now coordinate the time factor and optimize the usage. Industries we serve, of course, with mining, construction, agriculture, water treatment, stormwater, hospitality environments. The other thing to consider is that we can act as a pre-treat, a self-treat, or a post-treat, depending on the application. So that's a rather unique position to be in, because if we're going in as a pre-treat, we can augment something that's already there. We can use existing processes and infrastructure. If we go in as a solo treatment, we can utilize existing infrastructure wherever possible, really minimizes costs, and we have a very simple application to be able to add into the process. If we're going into a post-treat, we're optimizing something that's already being done, and we're gaining a much higher quality of water. Issues we remediate, of course, we talked about turbidity, heavy metals, nutrients, algae, erosion control, dust control we also do. So we look at preventative measures as well. So things like soil stabilization, slope stabilization, etc. But looks like Hank is going to be able to come on board here fairly quickly. So again, here's a periodic table where we've identified ones that we're very commonly able to take out. In the green, the yellow is ones where we're still able to remove, but we have to really look at the chemistry and dependence on the process involved. And then also the kind of pink color there is limited. And we do testing on it. We may have to combine some technologies to take those out. And then the ones in the white, of course, are either too dissolved or things that are gaseous where we typically don't get involved with. But we keep adding more and more to this process as our clients come to us and say, hey, can you take this out? Recently, we had fluorides. Can you take out fluorides? The answer was, yes, we can, up to 96%. Can you take out phosphorus in dissolved and totals? Yes, we can. So this is, we can, because we're the manufacturer and the inventor of the products, we typically invent 1 or 2 new formulations per year to answer to these other water streams and waste streams that we're dealing with. Very unique capability, unlike standard flocculation. So basically, everybody understands the result of a flocculant or a coagulant, what it does, but our chemistry goes far beyond the standard chemistry that's available. So we're not just creating a thickened process and then a combining and then falling it out. We have a very, very good process here where we're actually taking and not having to worry about things like pH. In most flocculation processes, pH is a critical part of it, and they are really limited by the pH in the water. In other words, if it's a 3 in a pH, it's very difficult to treat. They may have to do some crazy balancing to get it, or a 4 or 5. Or when they're up around 10 or 11, they can't get it out either. So one variation in pH can cause a problem with standard technology. Our technology allows us to work within a range of 3 to 12 without having any variability whatsoever in the efficacy of the product. So that's really kind of a unique scenario to be in. Because we started this in the mining, we were dealing a lot with the mining and oil sands, et cetera, in Alberta, we had to deal with temperature variances. For mountain mines, we had a lot of issues with freezing temperatures, and we do a lot of cleaning of water that are in frozen lake beds. and we have to treat the water that's below the ice. Temperature from freezing to boiling, we can operate with full efficacy in both of those. pH from 3 to 12 without any issues whatsoever. And if we need to make an adjustment, because our range is so large, it's just a small adjustment, very quickly and easily done with our equipment, and we can be operational without having to stop the process. So pH adjustment, we have a full suite to do that. Salinity is also one that we don't really have to deal with that much. We can treat freshwater, we can treat seawater. That makes it very unique when we're looking at RO systems. We can act as a pre-treat for an RO system to take out organic materials brought in from, say, oceans that are being pumped in, or for treating basically saturated saline-based waters that need to go back and be released into the environment. We can not have to worry about the salts. Typically, like I say, seawater is about 34,000 milligrams per liter, but we've dealt much higher than that. We've been over 100,000. One case, we're even up to 250,000 milligrams per liter parts per million. That's not typical, but we have done it. But for the most part, like I say, freshwater to seawater is very easy range. Operational resilience, this material is self-dosing. It does not require dosing pumps. It's a gel flocculant. Now that Hank's on board, I'm hoping that he's going to be able to do a little bit of a demonstration after I'm finished going through this process and just show you how the jar test works. So we don't require costly sensors. It's self-limiting. We don't need to have metering. We're not having a lag time. So as I talked to you earlier, I had stated that we were dealing with particle size, not necessarily getting to a particular volume in the water. So that gives us a very unique process in pulling out these particles, because the particles are gathered and bonded through the release based on the load factor. So if you have 100 milligrams per liter of TSS and you have 1,000 milligrams per liter of TSS, it's going to release the required amount to accommodate for that load factor. So if you have maybe nothing in the water, the TSS is like 1, it's going to release way, way less than it would at 100. So that gives us a very unique property as well, and gives us how would you say it, a long release time. So the gel flocculant blocks, if they're in situ and just put in an open channel, we'll see some pictures in a moment, will last anywhere from 8 to 12 weeks. And in some cases, we're getting as high as 15 to 18 weeks. But standard, as I said, about 8 to 12 weeks. And if you're in the reactor systems, the pipe systems that we have for mixing that we've developed, those are going to be about 2 to 4 weeks before they need to be replenished. So very high volume treated. One gel flocculant block, which weighs approximately 2 kilograms, will treat anywhere from 15,000 up to as high as 40,000 cubic meters of water. So this is kind of a comparative of a concentrated value unit versus a big, tote full of liquid flocculant or granular flocculant. So very, very unique properties. Environmentally friendly, we've won numerous awards. 2022, we won the Sustainable Earth Award. We won 2021's Clean Tech Award, which was an international competition. They chose 3 companies to be the winners. We were one of the 3. So we're very, very proud of all the awards we've won over the years. It's probably too many to mention. Our approach, again, is we utilize site-specific samples and layouts of documents to understand what the challenges are with our clients. And then we come up with a solution based on our gel flocculant and our ClearFlow technology that will be the optimum for the site. We do request that we get water samples so we can determine a specific match of our formulations to the water chemistry and the constituents that are in the water. And now we get into the wastewater fun. Well, I have been dealing in wastewater now since the first, when I was 6 years old and fell into a septic tank. I don't think life has ever stopped in that. Always been around water of some type. We developed a system called Accelerated Solids Removal Technology, or ACERT. The one I'm going to show you here is for 23 cubic meters a day treatment. It's a batch process, but they're scalable, and we've scaled up to larger units. You can put them in series as well, and even do higher volumes. We have a number of them in India going anywhere from 10 cubic meters per day up to, hundreds of cubic meters per day. So it's just a matter of seeing what's there. So our comparison is centralized wastewater treatment is becoming a big issue, mainly due to infrastructure and cost of running infrastructure to low populated areas. They're large, they're expensive to build and operate, they're complex, they require lots of money, lots of people, lots of technology and training to be able to operate them. And, they do have a bit of a limited user base. You have localized wastewater collection, and that goes to basically a sump system, which is dumped off at a centralized plant. They're inexpensive, they're portable, but again, manually intensive, etc. And then we get down to wastewater deposition areas. And this one particular picture is one of a river that we worked on in India, that we were treating the wastewater going into it so that we could minimize the impacts. It's pretty scary stuff in some of the sites that I've been to all over the world. What's missing is basically an innovative decentralized wastewater treatment process, which we feel that we've come up with. And in my 47 years of dealing in wastewater, this is probably the most efficient system that I've seen. I hate to say that sometimes, because I really sound like I'm blowing my own horn, but it is a reality, and we've been told that by many, many people that use it. So from the perspective of operational, it's very simple. You do not need to have multiple engineers operate it, and it can very easily be moved, transported, portable, or made to a fixed system. So what we do with decentralized systems and our ACERT system is we're basically minimizing footprint, timing and process, initial costs, training, ongoing operational costs, infrastructure requirement, installation and development costs, and maintenance costs. The core technology in the ACERT, again, is our gel flocculant, and it's very unique property when it actually deals with ozone, because we do have ozone that we've operated in this very low self-producing ozone system. But typically, to get to an ORP value of about 780, you're looking at about a 20-minute process. When we add the gel flocculant within our system to this process, we're gaining a huge amount of time. In about 4.5 minutes, we're at the ORP value required. So really a huge difference in operational capability and results. So again, we're providing a reusable water source for irrigation and toilet use. We're providing potential for reuse of the sludge material. The sludge that's based in our system, once it's done, that sludge material is basically inert after 24 hours, so it can be reused. It's not going to have the bacterial issues that most sludge materials would have. Again, less odor, less intrusive to the surrounding environment as well. So it's a physical mechanical process that ClearFlow has developed and patented. It allows for the removal of sediment within minutes, not hours, or days or weeks. Typically, if you were to put this beside most even decentralized plants that we've dealt with, our operation is within 3 hours, you're seeing clean water. We like to say 24, because then everything has happened, even with the sludge. And it will do about 5 weeks worth of work in that short time period. So it's a huge competitive advantage to have this process. We constantly are working with the National Research Council of Canada and University of Alberta. I represent as an ambassador for them as well. We're very heavily involved with doing continual research, and I lecture at the university as well, probably about, oh gosh, at least once a month I'm in there doing, helping students and PhDs finish off their graduate studies, etc. So it's very good where we're looking at, again, the all of the constituents within the water, TSS, TDS, BOD, moving it from the water down to the levels that need to be hit, and for reuse as well. So we're really looking at that, having an advantage of very clean water for repurposing. We're continuing to develop and research into much more applications, which, as we're finding as we go into different countries, various things that we're looking for. One of the advantages are that we get a lot of the metals and things out as well. And in much of the wastewater streams that we're dealing with in some of these countries, they do a lot of mining or close proximity to all their waste streams. We're having to take out some very nasty metals as well. So this process does it all in one. You're not having to add secondary process. Again, it's, I'm going to just move something here. Sorry. It's fully modular. It's portable. It can be trailered. It's enclosed for safety and security. It's a plug and play. We've made everything so it's field ready and field maintenance capable. So it's a matter of just changing out a pump. It just unplug one pump, put the pump back in. We've made it very, very simple for operational piece. We're all about the operations and making sure that it works for those in the field. It's scalable, it's simple to operate, utilizes commonly available components, localized, and ideal for urban and rural uses. So stage one in the process for the assert is multiple source influent water consolidation, loading surge tanks for volume control, utilizing macerator pumps to achieve particle size uniformity, and also looking at going into stage two. We have the influent water treated with gel flocculant and what we call fog links, which is a way that we're actually destroying the fat, oil, and greases and breaking them down, which most systems do not do. And they get a buildup of fat, oil, and grease, and they cause a lot of clogging. Whereas ours actually breaks the fat, oil, and greases down and makes it simple to incorporate into the process and releasing of the water. Stage three, sludge tank is transferred to, sludge is transferred into the sludge tank. And then we have a kind of an alkaline hydrolysis process that renders the solids inert, as I talked about earlier. Stage four is the treated water transferred to the clarifier tank, and then the stage five, of course, clarified water is disinfected and can be treated and released. So the process on a 150 gallon batch system is about a 20-minute batch cycle time. So real simple and easy. Basically capability, 1% expected solids of solid ratio, capable of handling up to 4%, 41 batches or 6,150 gallons of influent, 6,000 gallons of treated effluent is suitable, compliant for discharge. And we have about 360 pounds of sterilized solids available for secondary use. So really a simplicity and efficiency process, really high efficacy, and giving a lot of result in reusable materials. Results, this actually, if I look correctly, yes. So this is actually some results that we had done by a lab in India. And the reason that we put this here, if you look down near the bottom, they had a lot of metals. So they had iron, they had nickel, but they also had chromium, which was really, really a nasty factor. And so we actually were able to take all of those metals out and bring them down to non-detect. We also took the TSS down to virtually a non-detect factor. The pH, we just had to do a slight balance on the pH. And then the total dissolved solids, of course, reduced dramatically by about 8 times. And the fat, oil, and grease, if you can see, again, that's a big one for us. We reduced by 9 times. So the results are rather amazing on what we can get out of a very small system. Here's your raw sample, find the treated sample, very, very clear and clean. This particular unit, as I said, that when we were talking about, was the 23 cubic meter per day system, and really simple 20-foot C-can or containerized model. Setup time's about 8 hours and getting everything operational with the lift stations. Technical support is available. dimensions, say 8 feet by 8 feet by 20 feet long. Takedown time 6 hours approximately. We can arrange for site deliveries, etc., and it can be available to meet specific requirements. If you have some industrial waters that you have to deal with, we'll run some extra testing in our labs and make sure that we get the right formulation for that particular application. Here's one that's being delivered in a different country here. Just put it on the trailer, very nice and simple. So again, going into the repurposing and water restoration, we talk about different flocculant types that are currently available and have been available for many years through granular and liquids, and then now, of course, our addition of our gel flocculant. Granular is a pure product. It requires clean water supply, make down equipment, dosing stations, highly trained personnel, and a very high ratio of monitoring to ensure that you've got no negative effects on the environment. It's 100% active. You've got cationic and anionic, depending on which the application is that we'd be using. In many cases, we see anionics being used less than cationics, although that's starting to change a little bit. The cationics are very, very negative effects on aquatic life. They're slow to dissolve to become active. Typically, you're looking at a 90 to 120 minute make down to convert it into a liquid before you dose it. Most people do not wait that long and end up dosing out live product. And in those cases, we typically have a lot of animal kills or fish kills. Requires make down and dosing equipment, large volumes of clean water to make it down, because typically you're running at about 0.5% to 2%. No more than a 20% mixture, but typically 0.5% to 2% is your operational ratio. So you're looking at well over 90% is water. So the liquid product is active, less than 20%, as I just mentioned, and requires a lot of people to operate and can be having inhalation issues for humans as well from the dust that are off the granulars. Liquid, again, there's two types. There's the emulsions, which is the water and oil that's already pre-mixed in a specific blend. Again, you're still looking at about 70% of that is water and oil mixtures. Approximately 30% is active product and requires addition of a coagulant. Typically, when you're looking at the application, the equipment for them alone, I know what in North America, the equipment is about $200,000 to $500,000 per unit. So when you have multiple site units on a large location, it can become quite costly. So again, that's one of the biggest things, high cost to ship is mostly water in the product. They require make down and dosing again, shorter shelf life than the powders. And emulsifiers can almost always, the surfactants and emulsifiers are toxic to the aquatic life. So not great. They are easier to handle than a granular because this is already pre-made and ready to dose. So it does have, a couple of pros, but the cons typically outweigh that. Again, dosing stations, as we talked about, is a very high capex and operational costs. Their energy required to operate them and maintain operation gives them a higher carbon footprint and greenhouse gas emissions. Dosing pumps are expensive and very finicky to deal with. They don't necessarily always run the way that they should. Control and instrumentation calibration, and a huge amount of lag time, because typically you're doing a measurement off of your water quality that then gets transmitted back to through the sensor back to the panel. The panel then starts adjusting the dosing. So there's a big lag time in there, and that becomes quite a problem and a very high potential for spill and overdose. So this is our gel flocculant. As you can see, it's a block format or a slab format. They're about the size of a loaf of bread, about 3 inches high, 9 inches long, 5 inches wide. And they have a high tolerance for pH, as we talked about earlier, from 3 to 12. The broad temperature range from freezing to boiling, high salinity and tolerance range for freshwater, seawater. They reduce the sediments, metals, various nutrients, organics, VOCs, and levels of light hydrocarbons, and capable of reducing turbidity We say typically about 2% solids would be the high end. We have gone higher than that, as high as 4%, but typically we're working in a ratio of less than 2% solids or up to 20,000 NTU. And we're getting particle sizes that are nanoparticles. So we're down well below 1 micron in many cases, in most cases. They just need, for operational efficacy, compromised water. Then they need to have flow energy. So the process in the release, instead of having a pump that doses it, it's amount of flow that goes over them, and mainly the particle load. The higher the particle load, as I talked earlier, the more it's going to release. The less particle load, the less it's going to release. So, and it needs that turbulent energy to be able to cause the particle collision so that the particles will actually bind together and fall out. So very simple process. So flow energy is virtually what does the job, which eliminates tons of equipment. As you say, you don't have to have the dosing equipment, the monitoring equipment, you don't have to have the big flock stations, and you're saving hundreds of thousands of dollars in OpEx and CapEx. It's as simple as putting them in a stream. Here's 2 blocks in a stream right now. This is actually out on site. These are the gel flocculants in an open flow treatment. These are the ones that would last anywhere from 3 to 5 months. Typically, as we say, about 2 to 3 months, but I've seen them go as high as 5 months. We manufacture them under high quality standards. It's our own manufacture process, right in our plants in US and in Canada. We have different formulations that can be used independently or in combination. Their consumption rate is visibly discernible. So as I said, it's going to be based on the particle load. They do hydrate and they'll swell. And then when they get to a point of they're swelling, they're actually releasing. So they've been activated, they're releasing. Say the water goes away and they're bone dry and you have nothing for water for 6 months or a year. Water comes back a year later, reactivates them, and they're operational again. So again, a very, very unique feature. So zero carbon footprint. You're not using any energy. You just have to have them placed in the right spot. They are not, they're totally safe for the environment and fish and aquatic organisms, mammals, etc. And a very long shelf life. We say 5 years, but I have products that are in my warehouses that are over 10, 12, 15 years old that would still activate. That's an open flow treatment again. And as they say, operational costs are way, way below $1. As you can see, per gallon cost is, portions of a penny per gallon. Again, and we're saying that, 30 days, 60 days, up to 90 days application. So that's why we put the pricing range on there for those various operational timelines. If you look at a comparison to liquid flocculants, obviously we're considerably cheaper and much easier to operate. That comparative doesn't really compare all the notes in buying the equipment. So we're way, way cheaper. Conceptual setup of an open flow system, have the turbidity influent, put our gel blocks in place based on the flow value. We have a calculation, so many blocks per volume of flow. They have a mixing time, which creates the collision and the precipitation of the flocks. And then we have a gel flocculant 300 series, which causes the flocks to even bind tighter and heavier. And then we have the settling or the capture point. So then you have the released water is treated for discharge. There you go. Water sample 2 years old, water sample treated. So very, very big difference, substantial difference. We have various mechanical, semi-mechanical, but they're a passive treatment. Again, they just need pump flow. So there's no moving parts in the system. Basically what's happening is the water's flowing through these cartridges, the vertical cartridges that you see here. There's ones for various gallons per minute. As the water flows in, it actually reacts because our gel flocculant is inside those chambers or those cartridges, and the water reacts with that and then comes out and looks for a place for deposition for the solids. So there's a 50 gallon per minute system, 100 gallon per minute system. Here's one that's in play is 1,000 gallon per minute system and a 300 gallon per minute system. And we've now just introduced a new version of the 300, which is almost identical to the 1,000 gallon a minute system, just a smaller version. And as you can see, the only thing we need there was the pump. There's no moving parts in that, and there's just cartridges that get replaced on a periodic basis based on usage. This particular site is 5,000 gallons a minute we're pumping into 5 different reactors off of a manifold with an 8-inch inflow line and a 6-inch line going into the individual reactors. And this is a very large mine site. They now at this particular site have 26 of these reactors, and they're pumping all over the place to clean their water. We're actually moving a lake so that they can drill a mine shaft. So that's rather unique. Here's how simple the reactors work. And this will work for various ponds that have lagoons that are wastewater based as well. So it can take a lot of that material out and make it higher quality than what it is. And then it could act as a pre-treat for your systems that you already have in place. So as I said, we can be a pre-treat, a sole treat, or a post-treat. In a lot of cases, we can do even post-treat for your wastewater plants. If you're having a little high turbidity, we can do that final polish before we go. So as I say, here's a reactor, the primary stage in number 1. There's on the left-hand side of the unit is a 6-inch or 150 millimeter pipe that's got basically a flighting inside of it, creates a vortex energy that goes into the larger system, where you see picture number 2 is the cartridges. Each individual cartridge holds a certain amount of the gel flocculant slab inside of it. And then each of those cartridges get put inside of the larger body of the reactor system, the mixing system. And there's 6 of them in there. And this would be changed out every 2 to 4 weeks standard. And it has the right formulation as we deem based on the water testing that we've done for your site. And this will treat up to 1,000 gallons per minute. Again, the cost we've got is just astronomically cheap compared to what's out there. And the OPEX is very, very minimal. If any, just check your units every once in a while, make sure that they're still operational and having the water go through, and then replace the cartridges as required. Here's a larger version of this. Actually captures the solids as well. Instead of having a deposition point, we have some sites where they cannot capture the solids. So this would be the plant. So the water goes in the vertical stacks, which has the gel flocculant in it on the left-hand side, then goes to a specific treatment clarification in capturing all of the solids, and then the final water release to final polish, or just to release to the environment. So it's a zero carbon integrated flow process, zero carbon footprint. And again, we're going worldwide with this. So a little quick touch on stormwater. A lot of stormwater situations are being amplified by wastewater inflow to them, flooding especially how that happens. So with the flooding, you're getting a lot of fecal matter and other organic materials in there that are becoming almost like, sewage overflows are getting into stormwater as well. So it's quite important that we maintain the quality of our stormwater for repurposing and reuse as well. So again, the hardest state in the US to get approvals for is actually Washington State in Western US. And they have very stringent guidelines because of their proximity to the ocean and how much that they deal with the ocean. All of their studies, we are approved for use in Washington, but their studies, we were given approval in 3 weeks versus the 2 years that it normally takes or more, because they based all of their criteria on our technology for answering for other companies to come up and get their approvals. So they have to meet the criteria that we meet, and we gave them all of the initial data. So their criteria is based on ClearFlow product. So this is a very, very proud to have that as an approval, and the fact that we helped them change their process. This is a big infrastructure process that was being built and added to for a subdivision. They're adding quite a few hundred homes. And the federal government, National Research Council of Canada got involved. And the federal government of Canada asked us to prove that we could take out phosphorus because they were having really high phosphorus loads coming in and getting into one of their major lakes from all of these subdivisions and their stormwater. And as you can see, the average phosphorus removal was anywhere from 80% at the lowest point to as high as 98%. The averages were well in the 90 percentile in removal of phosphorus in the dissolve factors as well. We increased their efficiency. Normally you can get 20 micron particles or 40 micron particles with the storm pond design. We were getting over 80% of 20 micron particles and more out of the water, which they've never seen before. So we increased their efficiency of their storm ponds by 74%. Very simply put, we used existing infrastructure. We put our blocks down into their storm system and it reacted with the particles. And then when it came out into their storm ponds, it dropped all that material. We did some natural fiber material that we provide that's treated with our product as a final polish in the ditches. And the water went clean into the next level of environment. So very simple. Here's pictures of it in situ or in the, in the storm pipes. Nice, simple, easy to operate with. Doesn't cause any blockages. And we're just hoping everybody's having a great day. And pardon some of the connotations here, but just a little bit of a laugh at the end here. So we're globally proven. We're starting to globalize our company now. So hopefully this has been great information for you. We'll just open it to any questions you might have. Thank you.
I thank you, Derek. Yes, that was quite a bit of information here, and the floor is now open to the participants who are logged in. Should you have questions, please feel free to either unmute or put them in the chat.
Hi, hope you can hear me.
Yes, Timothy, go ahead.
Yes, Augustus here from Trinidad and Tobago. Very interesting products you have here. Wondering if it would be, or if you have tried it out on very difficult waste, leachate, and the other one is distillery waste, rum distillery waste.
The answer is yes to both. On the leachates that we were doing a lot of leachate applications for waste dumps. And one of their biggest issues was metals that were getting leached out into the system and they needed to take them out. So we helped them design a capture point in a process flow in situ system with a channel, and we're able to do that. And in their ponds, we use their reactors. So yes, we're quite cognizant working with leachates, especially when we're dealing with mining so much as well. We do that constantly, pretty much every day. And then when it comes to the other application you're talking about, yeah, we have had experience with that as well. And in some cases, we had to do a combination. We also do some granular products as well as our gel flocculants. And in a couple of those cases, we had to combine the two. But yes, we have done both.
We'll definitely have to be in touch. I'll be in touch with you.
Excellent.
Jerry, I don't know, I know you're not in your office right now, but when we were talking, you showed me that little physical test that you did. Are you able to show them that?
I am. I was hoping that I was trying to get a hold of Hank to see if he could do one. If not, if everybody could give me just.
I'm on camera, Jerry. If you can see me.
Oh, excellent.
There you go.
Hi, welcome, Hank.
Sorry, I'm sorry. There we go. Hello, everybody. I earned my my IT degree today, reconnecting cables and getting us back up. And hi, Valerie, how are you?
Very good, thank you.
I'm
I
happy
just
to.
want to say that because I have to leave or switch over to my iPhone in a minute. I have to go to a medical appointment, but I think that this is perhaps one of the more important webinars that we have had. Noticing, as I've worked in the wastewater industry in the Caribbean for a long time, and knowing the challenges that are there and the costs that are there. Don't hold it so far. Yes, it's yeah, that's better.
Okay. I'll let Jerry walk you through it, but I'm going to take some of this construction site, mine site water. I'm going to add it to a cup where we've got some gel flocculant in it, just a couple of pieces of it. And Jerry will walk you through my barista movements and show you how we are able to precipitate out the sediment and treat the water. So I'm going to do that right now. I'm going to pour some of that into the cup for you.
So
And
typically,
one thing I just
Sorry,
if I
Valerie.
can just say before I go, one thing I have suggested to Jerry and Hank is that they actually perhaps come down to the Caribbean conference, because I think this is such an important topic and an economical way of treating wastewater that would be very useful. I'm hoping that they're going to come down to Trinidad next October and present down there.
I'm really
I'm
thinking.
going to switch over to my iPhone now.
Excellent. Thank you, Valerie. I think that that's probably a really good idea. And actually, one of our staff who's just retired due to a health thing is actually from there. So I know a bunch of his family down in Trinidad. So hopefully we'll get an opportunity to see our friends there as well. So, but I think that's a good plan. So anyways, Hank, if you want to expand your screen again here, we can chat about that. And thank you again, Valerie, for everything.
I'm
So
not sure how
there
I
we go.
do that.
Yep, you're on
Okay,
now, so I
good.
can see.
Okay,
So-
I'm just going to go ahead, Jerry, walk them through it.
Yeah, so basically what we would have done in advance is we would take the water sample, we would have tested it to find the best formulation, because we have multiple formulations of this gel flocculant. Hank, are you able to show them a piece of the larger block or one of the blocks?
Yep, I can. Let me just finish doing this here.
And so what Hank is doing is providing the flow energy to cause the particle collision. And what you'll see is that the pin flocks will start to build and we're getting separation pretty quickly. And as you say, it's clearing up more and more as it goes through. So
there's the original water.
and that's typically in 10 to 45 seconds, we're getting those reactions. So now we have a water that we can put a final filtration on, we can reuse it, we can release it. Of course, if there's deleterious chemicals in there, you always want to do a double test or metals and make sure that we've taken those out as much as possible. But there's one of the blocks Hank's got in his right hand there. That's a 300 series block we use to bind the larger particles to make them strong and firm. We don't have to worry much about flock shearing, which is another big thing with the liquids and granular competitive products, is that these blocks, because they're designed to hold together as a gel initially, they also hold the particles together very strong. So we want high energy flow versus if we put our other competitors under that high energy flow, the flocks would break up. So it's a totally different science. But as you can see, very clear water in a very, very short period of time. Thank you, Hank.
You bet.
Well,
Any
this looks like a pretty good solution for our high turbid waters during the rainy seasons in the Caribbean. And that should be of quite some interest to many of our operators. Do you have any questions or comments? Please feel free. I'm not hearing it.
Done my job?
Well, I think
Oh, there's one here.
somebody in the chat room is asking us, Savage, Truth, how effective would it be to, oh, sorry, I lost the, let me get back to the message.
Looks like a pre-treat for RO. I didn't catch all of it, but it was something.
So let me get the chat. Not finding it, just a second. Okay, it says, how effective would it be to use that in place of the conventional MMF for RO?
So typically for RO systems, what we do is we act as a pre-treat, because in a lot of cases, the ROs, is because we don't, we're not that sensitive to salts, we're not taking salts out. So, but that being the case, that gives us the opportunity to deal with really high salinity waters, ocean water, as I said. But what we're doing is we're creating a larger flock that can be captured. The flock still has to deposit or be captured somewhere. So you'll still, like we're doing a design right now with one where we're having a sedimentation tank, then it's going into a dual media filter and then into the RO system. And that way we're protecting the RO membranes, and it elongates the life of the membranes. We're saving the client. One client alone, I think, was about $750,000 per year. We're saving him in replacement of membranes. So it can be quite effective. The thing that we need to consider, though, is we're not eliminating a particle. We're creating a particle that's big enough to capture. And the reason I'm saying that is because in many cases, depending on what the source water is, there could be organic flocks, and organic flocks, even though they get very large, can maintain a light and fluffy with a very unique specific gravity that won't allow them to settle out, but they will float through the system. So yes, we might get the heavier clay silts type of thing that we can have deposited into a tank, but you would still need to catch those organic flocks that would be floating in a larger embodiment. So that's why we act as a pre-treat and make sure that we have some form of deposition and filtration prior to its release into the RO.
You do have you kept saying that you had a zero carbon footprint and you use gel flocculants that can last up to 2 to 5 months. What any side effects on the water systems from these gels?
We haven't had any. So if we're depending on, so what we would look at is, first of all, the positioning of them, where they would position within the system or prior to the system, so that because what can happen is they'll hydrate, they'll get kind of like a bit of a bulky mass. They'll go from about maybe double the size, and then it releases, but you'll get some polymer strings, if you will, that might come off of those. But the dilution in the water, it stays so tight that the dilution in the water is going to be releasing based on the particle load. So you're not going to have a lot of residual. Like you can put, Hank could put his fingers in that jar that he just tested, pull it up, and there's no residual, because this is based on particles, not just dosing the water. So as you can see, when you're lasting 15,000 cubic meters to 40,000 cubic meters of water for a block of material, and we're calculating a flow of, say, 1,000 gallons a minute, that would be the equivalent to 20 blocks. So we look about 50 gallons per minute per block. So 20 blocks compared to 1,000 gallons a minute, 24 hours a day, there's going to be nothing that's going to have an impact on your downside, because there's no residual enough to release, unless the whole block released and went into a pipe and plugged. That's the only way that would happen. So again, we look at where it's positioned, so we optimize where the deposition point, and we can back calculate based on the deposition point, because we know the time factor of usage from reaction to deposition and settling. And there's no negative effect to environment anyway, so they're safe to, you can eat it, it tastes horrible, but doesn't hurt anything. It's all standard drinking water chemistry. We've just figured out a way to make a very unique way of formulation it.
Right. Yeah, there's what effect does the gel flocculant have on the pH? And if it does, what do you use to bring it back?
It doesn't have an
Gel
effect on the
Francis.
pH because it's not pH sensitive. So because it won't adjust, because it won't be affected by the pH in a pH, say, range of 3 to 12, let's say, it doesn't adjust the pH. The most variability I've ever seen is like maybe a half a pH, a quarter of a pH, but it doesn't adjust the pH at all. It just does not affected by it. Similar to the salts, we can't take the salts out, but we're not affected by it. So we can operate in high salts. Same thing with the pH.
Any other questions? I see none.
Good. Well, I really want to thank you for taking the time to listen to us. Valerie and I've had some interesting discussion. We know a lot of people from the past that really, it's exciting what's going on in the world for water, and for us to be able to expand globally based on the simplicity of the technology, but it's complex. It's a complex simplicity, which is no other way to explain it. The chemistry is complex. It took me years and many millions of dollars to develop it, but it all started with a fish tank in my basement, and now we're distributing to 7 countries. So it's been a lot of fun this last 20 years. So thank you for your time.
Well, we'd like to thank you for joining us and sharing this invaluable bit of information. And as Valerie indicated, we look forward to us to meet maybe later this year at the CWWA, if you can make that. And also that some of our operators here may be able to share some of that information with their principals at their various utilities, who may also have some interest and would follow up with you about your product.
Sure.
But we'd really like to thank you immensely for making the time, both you, Hank, and Jerry, for joining us this afternoon
Yeah,
in our
thank you.
CAWASA Wednesday webinar.
Excellent. Is it possible to get a list of the emails, and we can forward this, or your direct email? Maybe we can forward this.
Sure.
and
I
to you guys?
will at the end of the session, I will get that from the Zoom link, and I will share that with you. All the
Excellent.
people registered on the forum. Yeah.
Excellent. Well, thank you so much again. I wish you all the best, and I hope to meet you very soon.
Right.
you.
Thank you very much.
Okay.
Wonderful
And
week.
we'd like to thank all of you. I'm Ignatius Jean, the Executive Director of the Caribbean Water and Sewage Association. We're based in St. Lucia and serving 12 of the water utilities in the Caribbean region. Thank you very much. Have a good evening, everyone. And we will be
Cheers.
sharing the link. And we also post it on our YouTube page. Bye now. Signing off.